we gotten to the point where we might know why the thyroid is important? No, we haven't gotten to the point yet. Okay? Yes, very important for thyroid hormones. What you will learn, okay, is that thyroid hormone is important to all the cells in the body. All right? It's why the hormone is pretty much found all the time in the blood. Okay? Every single one of them is important. There's not one that isn't. Okay? When they are not present or not working or not functioning correctly, okay? For example, in the case of the iodide and the thyroid, ever heard of hypothyroidism? Hyperthyroidism? This is why. Muscle cramps could be calcium, sodium, potassium.
Is that why we're always told to eat a banana for having a cramp?
It could be. Now, that's because the banana is going to be providing a good source of the potassium. Usually, in the case of the muscle cells, potassium is one of them that can be utilized first because the cell is most permeable to that. But then again, but it would be a little more serious. It might be the sodium, but that would have to kind of get diagnosed.
Yeah.
You'd have to have constant muscle cramping, that sort of thing. Yeah. So these ions are important, but don't dismiss the covalent bonding. And when these elements bond from the periodic table, okay, when we get two or more atoms combining, we're going to form a molecule. For example, carbon to hydrogen would be a molecule. I have an element / atom, okay, atom to atom, and therefore I have formed a molecule. If I get carbon to all 4 hydrogens, still got a molecule. A compound is where I get 2 or more different types of, molecules are going to be the same ones. Sorry, my mistake. Y'all can get me out, a little bit later. Hydrogen, hydrogen. So under a molecule, hydrogen readily combines to itself, oxygen readily combines to itself. Those are the 2 that I can think of for our human bodies. Out in the world in general, others combine to themselves, but they're not in our bodies. All right? When we get 2 or more different ones, we get a compound. Water, H2O. Glucose, C6H12O6 is a good example of a compound. The molecular mass, I'm not going to ask you a whole lot about that, but molecular mass is just simply taking the atomic weight of however many that you have and adding them together. So if I had a compound, let's say I had a glucose molecule, C6H12O6. Well, if I have 6 carbons or 12 or 6, whatever the amount, find their atomic weight and add. But I won't be worried that much about that part. Okay? So, these molecules, these compounds, they work together to create our components of life. When they combine, the forces that exist between them, we are going to say that their bonds they create can either be weak or strong. They're intermolecular forces. Some of the bonds that get created are stronger than others. Covalent bonds tend to be a little bit stronger than ionic. Ionic tends to be a little bit stronger than hydrogen bonding. So these forces that exist will determine how stable that product is. Is everybody kind of following me so far? Any questions? Okay. The next type of bond, now, under strength, hydrogen bonding is usually considered the weakest, but hydrogen bonding is strong. It's weak, but it's strong. I know. What is she talking about? The hydrogen bonding that they're showing here, water. Water. How many of you encounter it? Seriously. I'm being serious. All right? How many of you may go swimming? Or to oceans, lakes, rivers, whatever the case might be. Have you ever noticed that as you move through that water, it looks like it sticks to you? Have you ever noticed that? You will now. Have you ever seen the creatures, like the little bugs and stuff, that can walk across the water? Now, think here for a second. Okay. Our planet, roughly 75% water. Our bodies, roughly 75% water. Our cells, roughly 75% water. Some people might say, oh, it's just a coincidence. I don't think so, but that's just me. Okay? Water. It is the only substance on the face of the planet that can exist in all three states. It can exist as a liquid, a solid, and a gas. There is no other substance on the face of the planet that can do that. And here we are, 75%. And I've just said it's hydrogen bonding. It's weak, but it's strong. Here's the reason why with hydrogen bonding. In the case of water, all right, this one, do you notice how rather than just being a straight molecule straight across like this, it's bending? Okay, so we see that electrons are being shared. Therefore, it's covalent. Okay? And the bond that's getting created between the oxygen and the water, okay, that hydrogen and the oxygen, the bond that's being created is hydrogen. In the case of this particular molecule, because oxygen is so huge, if you look at the periodic table, oxygen is number 8 on the periodic table. That tells me that after my nucleus, I've got 2 electrons in that first shell. How many do I have in the outer shell? 6. Because if it's number 8 on the periodic table, that tells me 8 electrons. Okay? So now I've got 6 electrons. How many does it want? 2. Okay? 2. So now it can readily combine to a hydrogen because hydrogen has 1. But that only gives me 2 little hydrogens out here on the molecule. So as those electrons are being shared, the majority of the electrons stay around oxygen and therefore gives oxygen a slightly negative charge and keeps hydrogen slightly positive. Now, it's not an ion, okay? It's covalent. It's sharing. But this structure is unique because if I have a little bit of a negative charge on one side, positive on the other, opposites like to do what?
Attract.
Only in chemistry. Okay? I know, lots of talk about, oh, opposites attract. Usually that works really well in chemistry. So, where I have a slightly negative charge here, it will connect to that slightly positive charge on the next one. This right here would connect to the slightly negative here. Over here, a negative. Oh, do you see how I'm going? Because water does that, and because it's hydrogen bonding, what this allows for is for those water molecules and the bonding that occurs between them to break, reform, break, reform, break, reform, break, reform. Water in its liquid state is doing this constantly. Those hydrogen bonds are constantly breaking, forming, breaking, forming. When water becomes solid, we call it ice, okay? The hydrogen bonds stop. When water boils and we see steam, we have broken the hydrogen bond. Therefore, water is the only substance on the planet that can exist in all 3 states. And it's because of its structure. Now, what does that do for some other stuff that's going to occur in the body? If we think about the salts, because that's what they are really, okay? And if we look at the structure of water, water has some negative and positive. Salts have negative and positives. We just said opposites like to attract. if the salts are so important